Okay, let's get started. So in today's demo, in today's tutorial, we're going to be creating a tornado effect, and we're going to be working on kind of the visual look of this. How do we achieve this? And we're going to build this kind of physics, a little physics kind of script that will kind of give it this kind of effect, kind of work its way up. So I'm going to do a file new here, and let's start from scratch. So we could try to build the tornado using some built-in primitives, the cone, etc., and try to bend it and stuff. But in this case, I found the easiest way was just to kind of search Google Pauli for a tornado object. And when I did that, I found this thing right here, actually, which worked quite well. And that's what I ended up using to do this effect. So that's what we're going to use today. I'm going to download it. This is by Robert Mirabel. And then we're going to take this and we're going to modify it a little bit to kind of get it to do what we want it to do. So we're going to download it and then import it into our space. Import as optimized, this tornado object. And when we do, we get this giant cone-like structure. So before we start modifying its materials, let's get it to process correctly around the center. So right now the problem is if I rotate this, you'll see that it's not going to really rotate around the center of the spire. It's kind of the center of this thing is kind of such that when I rotate this thing, it kind of rotates around this weird kind of middle point, and we want it to really rotate around where the spout actually is. And so to do this, the first thing we're going to do is I'm just going to create a little animation that rotates it around the y-axis, so we can kind of modify it in real time until we get it to look like how we want it to rotate. So I'm just going to select it here, go to the transform, and I'm going to, on the rotation here, I'm going to attach a signal controller. I'm going to then create a waveform signal. I'm going to set the amplitude to 360 because we want it to rotate a full 360 degrees. And then in the waveform signal, I'm going to set it to a sawtooth so that it kind of does a continuous rotation. And when we hit play, we get this kind of continuous effect, rotation effect. So now what I'm going to do is I'm going to go in and modify via mesh modifier. I'm going to try to add a rotation to kind of get it to process about that middle point. So the first thing I might attempt to do is to use the vertex transform. And when I do that, I can now apply local rotations here until we can kind of get it to look right. And it's actually quite hard in this case to find a rotation that it's going to work. And the reason why is because the center point of this is at the bottom. We really want the center point to be at the top of this object, and then we can rotate it from there. And so to do that, I'm going to add a mesh modifier called align pivot. And I'm going to make this, I'm going to drag this so it's the first modifier applied, and then I'm going to set the y-axis to the maximum value. So notice that when I do that, the top of the, I've just moved the origin from the bottom of the object to the top. So now we can rotate it relative to this. So now I'm going to, on the vertex transform, I'm going to rotate it until we kind of get it so it looks a little bit better. So that's better there. That's not good. That's better. Keep playing around with these values. And that's probably pretty good. So I've now rotated it. So again, the origin is at the top, and I've just found, and then I've applied a rotation relative to that by playing around with these local values here in this vertex transform under mesh modifiers, until I found something that kind of rotates now about its pivot, about the cone pivot at the bottom, which is what we want. So that's pretty good. I think that's kind of what we want here for this. So again, it's important to be aware of these kind of what we're doing with these mesh modifiers. We're kind of working in the object's local mesh space, and we're kind of modifying it. We're transforming all the vertices until we get something that kind of conforms to what we want. So then when you apply transforms at this level, they rotate in a way that we want. And so this is a good way to kind of pre-process the mesh this way. So we took that original mesh data, we pre-processed it, so to speak, by shifting its pivot and rotating the vertices a little bit, and then once we had it processed correctly, we can now apply transform animations on that process data to look like how we want it to look, which in this case is to kind of rotate about the spire, or about the spout at the bottom. Okay, so that looks pretty good. Now I'm going to modify the material a little bit so we can get it to look a little bit better. So I click on it, go to materials, I click on this default material, and one thing we're going to want to probably do is let's get rid of the specularity. So I'm going to set specularity to 0. I think also a two-sided lighting might look nice, and I'm not going to have it cast shadows. We start getting this little bit. In fact, if we go and look at pictures of tornadoes here, tornado images, we're trying to approximate kind of this fluffier kind of undefined edge look here. And I find like it has this two-sided lighting is a feel to it as well. If I turn that off, it's like kind of lit too uniformly. And once I guess it works either way, actually. Honestly, maybe we won't turn it on. Two-sided lighting is like light goes through it basically, whereas this treats it more like a solid object. Hard to say. Depending on the tornado, it could probably be, if it's wispier, then light goes through. We could try it without two-sided lighting for now. Okay, and then another thing we might want to do is apply a displacement map on the geometry. So this was, I fiddled around with this for a bit until I got something that kind of looked interesting. A wind rustle. To get that kind of fluffy edge is kind of what we're trying to achieve here. I'm going to do a noisy. Mess around with the direction, speed here. Amplitude. Actually, let's turn on the two-sided lighting. Maybe that does look better. Yeah, that's better. So two-sided lighting will actually make this effect look better. And another thing we want to do before we mess around with these parameters a little bit is I'm going to, in the translucency, we also want it to be alpha blended. We're going to just fade it out a little bit. And maybe instead of being whitish, we'll give it a little bit more of a dark look here. It has a texture on it, so we'll leave that actually for now. So I'm just going to fade it out here a little bit through the opacity. So that looks a little bit better. I'm going to keep modifying the geometry here, these values here, until we find this kind of fuzzy look. I'm going to give it a fuzzy edge. So that's interesting. I think that looks pretty good. Play around with the animation speed. Okay, and another thing I'm going to do is speed up the rotation. That signal that we added, I'm just going to speed it up a little bit. It's a little bit more crazy like that. And one other thing we might want to do is to get rid of this hard edge at the top, we could also apply an opacity map on the vertical axis. And so for this, I'm going to load a translucency map, or opacity map, and I'm going to import a texture I created ahead of time, just this gradient here. And a couple things we have to do here. We need to, since the UV coordinates of this object, in other words, how that texture is applied on the surface, most objects come with a set of UV coordinates. That's the artist that defined how texture should map on this object. In this case, we just want to map the Y value to our vertical axis. Our gradient is this, essentially. It goes from opaque at the bottom to transparent at the top. We want to map basically the Y values of this to that gradient. And to do that, to the V value of the UV coordinates, to do that, I'm going to apply a rotation along 90 degrees along the x-axis, and then a couple other things we have to do is clamp it along the V so that it doesn't tile the texture, and we have to also rescale the y-axis here, and then take it from the local coordinate. So basically, what we're doing is I'm going to take the UV coordinates from its local coordinates. That's going to map literally the x, y, z values of the object to the UV coordinates, the values that it uses to sample our gradient texture. So I'm going to use the local coordinates. I'm going to sample the alpha channel, and I'm going to clamp the v values, the y-axis, so that when it reaches the edge, it doesn't keep tiling the texture. I'm going to scale it. Since this object in world space is 0 to 100, it's basically 100 in height. I want it to go from 0 to 1, so that it samples our texture from 0 to 1, from the bottom of the texture to the top of the texture. So I have to resample it down to 0.01 along the y-axis, and then I have to rotate along 90 degrees the UVs. This is a long story short. This is just to get this kind of gradient, this texture here, to map to the vertical axis of this object. So you don't have to worry about it. I mean, this is just something I fiddled with. We don't have to do it. It looks fine also without it. But by having it, it kind of creates that faded out effect. Okay, so we have an object that looks pretty good. I'm going to keep fiddling here. Geometry. Kind of get that interesting effect here. Again, maybe fading this out a little bit more. This all looks pretty good. No specularity, illumination. Yeah, we do want to do the two-sided. I think that's what we decided here. Play around with these parameters here. But I think that looks pretty good. So the next thing we're going to do is, let's see where it is here. we're going to add the physics effect now to kind of funnel things into it. Oh, actually, before we do that, let's add a particle effect at the bottom. This represents like particles and bits and debris kind of being picked up from the ground. So I'm just going to create an emitter, particle emitter. I'm going to create that in the space. I'm going to child that to the cone, to our tornado, which I'm going to rename to tornado here. And I'm going to just zero out this thing's x and z coordinates so that it's locally at the bottom of our tornado. And let's just hit play, see what it does right now. That's not very good. So that's going to keep tweaking the particle effect here. We might have it kind of come out with a higher velocity. Maybe we'll have a negative mass. Let's crank up the number of particles that are emitted here. You can see this the row here. I'm going to set a cone angle. Maybe add a radius here. And also on the particle material, I'm going to set this thing to be alpha blended. And let's give it a darker color. Particles here. Start to see them there. Maybe make them a little bit bigger. Scale them in a little bit. And I'm going to shorten their lifespan as well, so they kind of disappear sooner. Maybe I'll lighten them a little bit. So the color of the tornado. Okay, that looks pretty good. So as we move this thing around here, those particles will move with it since they're in local space. And it looks pretty good. So finally, what we want to do is add our physics forces so that objects will be attracted to it. And so to do this, I'm just going to modify under physics attractor. I'm going to modify this attractor. I'm just going to create the attractor in the space. I'm then again going to child it to the tornado, and I'm going to zero out its x and z axis so that it's in the center of our parent, which is the tornado object. So if we look at what it does now, if we create some objects here, we'll see what the attractor does here. You're going to see that they're just going to be kind of attracted to the center point of the attractor. But they're not going to be kind of propelled upwards, which is what we want for the tornado to do. So we're going to modify this attractor. So I'm going to edit its code. And here's the attractor code. And we actually showed you how to create this from scratch in a previous tutorial. And we're going to just modify it here. So one of the things we want to do is, as it approaches the center point of this tornado, we want it to kind of add an additional vertical force. And so to do that, so this is like the attract me to the attractor itself. And now I'm going to do a attract, as it approaches the center, we're going to add an upward force, which is, so essentially it's going to be apply central impulse. And we're going to essentially, what we want to do is apply a 0, 1, 0. So that's like a 1 upward facing vector. And we want to apply it based on some value. And the value is going to be similar to the value that we calculate here, the distance to this object. So we can actually just see what happens if we were to just straight apply a similar value that we do here. So it's just saying, instead of using the direction to the center point of the emitter, kind of go upwards instead. And they're kind of now attracted to kind of an upward position of this, which is not great. We kind of want it to be attracted to the center first and then kind of go upwards. So we just need to modify our inverse square formula here. So this is not really inverse square, by the way. This is a modification of it, because it's going to do the division first and then multiply by the distance. This creates a nicer attractor. A proper inverse square has, if we put it in parentheses, a distance, that means as it approaches that distance, this will get really strong, which is kind of what we want for this. And we may have to tweak it from there. So we're just changing our formula that's normally used to attract. This is like not quite an inverse square, kind of is a uniform. It performs more of a uniform attraction all around the space to the center. This is more, as it approaches the center, it gets much, much stronger, so it ramps up much faster. So we're essentially changing this value and then applying it here when we're applying that upward force. So let's see what happens. So as they approach the center, there's going to be a singularity where they're going to start to kind of move upwards, and we may have to exaggerate that to see it. I'm going to multiply this by 30. It's still not strong enough. to work their way up. So let's see what happens if we make this 100. I'll move these closer. Okay, so we're getting a little bit of lift now. But not really enough to kind of override this. Times 1,000. Okay, so now they really start to lift as they go to the middle. So that's interesting. One other change that we might want to do for this is we can, instead of thinking the tornado really attracts objects all around it, it doesn't just attract it to the center point at the bottom of it, it's going to attract the objects all around it. So let's modify this so that instead of attracting to a single point, it's going to attract to a line that goes up through the middle of the tornado. So in other words, objects will be attracted to the center point of the tornado as opposed to the bottom of the tornado, so that no matter where things are, they'll always be kind of attracted to the center. So to do this, we're just going to change kind of the attractor logic here. So we're going to create a segment, and that segment is going to be comprised, it's going to go from the world space position of our attractor. That's the attractor node that lives at the bottom of this. So that's its world space position. And then we're going to we're going to build the segment to be from there to a value going straight up. And I'll explain what this will do in a second. We know it's about 100 in height, this thing. So what this is going to now do is it's going to define a segment that goes from the location of this node here straight up to the top of the tornado. And the segment object has a function that we can call on it to get the nearest point, to a particular point in space, i.e. wherever this object is located, get me the nearest point on that segment, which will be a point along this vertical axis. And so get nearest point, and we're going to just plug in the position of each individual object that we're iterating over to attract. And that's going to be the point that we want to attract to. So instead of the attraction point being the world position of our attractor, it's going to be this point along this segment. So gravity is still going to obviously override, and so objects are still going to fall, but now they're going to be attracted to the center of this as opposed to the bottom of this tornado. And that singularity now is way too strong, since now the forces are more balanced. And so I'm going to go in and reduce this down a little bit to 50. Still kind of strong. Another thing we could probably do is to eliminate this singularity that we have here. To eliminate this singularity, let's apply the force proportional to our distance from the center of this object, but minus some dead zone, basically, so that there'll be a larger area where the attraction goes straight up. So I'm going to say the distance, I'm going to divide it by 10 units. I'm going to take the inverse of that, but I'm going to subtract this by 10 first. So basically what's going to happen here is, I'll explain this in a second here. We're taking the distance that we are to the center of our line segment, to the center of our tornado. We're subtracting 10, so that means if I'm within 10 units of the tornado, this goes to 0. And then we're dividing by 10. So this will go to 0 when we're less than 10 units away, and then greater than 10 units, basically from 10 to 20, it will be a value that goes from 0 to 1. So this essentially creates a value that creates an inner radius. You can think of an inner radius of 10 units, where it'll be at 1, basically, this value, because it's 1 minus whatever we calculate here. And then as we go outside that inner radius, that value is going to go from 1 to 0 across 10 units in space. So that's what this formula does. So now we can multiply by this. Or actually, we can multiply our distance by this. Let's see what happens if we do that. Yeah, so now we have a much larger area in the middle that acts as our singularity, and we'll reduce this down. So our area, our inverse square area in the middle, that causes it to really pick up, is much larger now. So it's not just at the center point of this, but it's still not good. Let's scale instead. Again, this is always just experimental here. Instead of scaling of distance, let's actually apply this as a force over here instead. So we scale our force a bit more, but in a larger radius here. So that looks pretty good. They really get flown out. I'm going to reduce this to 5 maybe. And let's create a lot more objects here, maybe some smaller objects. Some of these things are really being flung. But it's kind of what we expect. Really small objects really go flying, and bigger objects are more contained inside this thing. And then what we can do is we can go and import some additional things. Let's say we get a house here from Google Poly here. Let's find a house. This house here is pretty good. I think I already downloaded this. Import that. House. This house comes in way too big here for our space, so I'm going to apply a couple of things here. First of all, I'm going to, on the house, I'm going to add a mesh modifier to align its pivot. It centers it, the pivot to the center of it. And then let's scale it down by adding a vertex transform. 0.1, 0.1, 0.1. So now we have a house that's about the correct right proportion. And then I'm going to add a rigid body to the house so it moves in the space. And maybe we'll create another house here. Give this a random rotation. And then we can also import some trees from Google Poly. So the house was Poly by Google. Let's import a tree, which I found also Poly by Google. A tractor. This one is also Poly by Google. Again, I'm going to perform the same mesh modifiers on it. I'm going to align its pivot, center. And then I'm going to add a... Actually, this is good. And then I'm going to add a scale to this. So I'm going to add a vertex transform. Scale it down. That, and I'm going to add a rigid body to this. So now we have a tractor in there. Let's import maybe some trees. This is a tree by Poly by Google, I think. Same story. I'm going to apply a mesh modifier. I'm going to just do an align pivot. I think the tree scale is correct. And I'm going to add a rigid body to the tree. We'll create a bunch of these. Take these random. So now we have all these things getting sucked up into this thing. And I'm going to add some clouds here. Dark. Crank up the wind here. Maybe make some terrain in the background. It's far, far away. Or not. And normally we kind of film these kind of tornadoes really, really far away using a telephoto lens. So I'm just going to go to the camera and set the field of view here. I'm just going to zoom in here. And there we go. Maybe we'll add a filter, an image filter here to make this a little bit darker. Add an overlay color here. Kind of give it a slight moody colorized effect here. Dark blue. There we go. Our objects are getting flung away. And another thing we might want to do is animate the position of the tornado randomly, have it kind of move around the space. So for that, I'm just going to click on that parent tornado object, and I'm going to add, we added a rotation waveform signal to its rotation, but now I'm going to add to its position. Add a signal controller to its X position. We'll have it move randomly, random signal, about some distance. Slow that down a little bit. So now it's going to move around along that axis, and then we'll do the same thing along the z-axis as well. I'm going to add a signal controller, new random signal, give that a bit of distance, and slow this down a little bit. So there you have it, a tornado effect, and the modifications that we did to the attractor to achieve this. And again, just to kind of go over a little bit of what we did here, because I kind of did a little bit of this on the fly here. We created a segment that's defined from the point of the attractor all the way to the top of the terrain. All the way to the top of the tornado. We kind of define a line, and then that segment object, that line object, has this function called get nearest point. It gets us the nearest point to the tornado from wherever an object happens to be. We then calculate our attract. We attract to that location instead of to the point of the attractor itself. And then we apply a vertical force using this formula here. This formula here basically says, given a distance, by taking our distance subtracting by 10, it creates a radius around our line segment in the middle up to 10. That makes this go to 0. So that means we're applying, since we're going to take 1 minus that, we're going to apply maximum force. Actually, and there's one other thing we might want to do here, is we want to limit this value, f. So we say if f greater than 1, then f is equal to 1. This is important. Else, if f is less than 0, then f is equal to 0. So that ensures that we don't go past 1 in this case, which we'll never actually go past 1 in this case, because our distance can never be less than 0. So this will always ensure that we'll always go to, we won't go underneath that, but we can go greater than that, so this just kind of limits it a little bit more. So I hope you enjoyed this. Let us know if you have any questions, and we in the Discord channel, and we will answer away. Thanks for watching.